Let's talk about factorials and factorial notation, because this is going to come in handy when we start doing counting problems. So what is a factorial? Well, a factorial is just if we have some integer, like say 7, followed by an exclamation mark. And what this represents is we take that integer and we multiply it by every integer before it. Only for positive integers though. Times 2 times 1. So that is what 7 factorial represents. And if we have, say, 2 factorial, that is going to be 2 times 1, or, just 2. 1 factorial, quite obviously, is just equal to 1. And interestingly, if we have 0 factorial is also equal to 1. There's a very interesting proof of this, and it's actually quite elegant, and I advise you to check it out. But yeah, just generally, these are what factorials are all about. And hopefully it's quite straightforward, but I'll, do another example. So say we have, 5 factorial. You can see that's going to be 5 times 4 times 3 times 2 times 1. And oftentimes we don't even write out this times 1 just because it's, so redundant. So let's think about what happens when we divide factorials. So let's say we have something like 8 factorial divided by 6 factorial. Well, let's write this out, maybe see where it's going. So if we have 8 times 7 times 6 times 5 times 4 times 3 times 2, and that's all being divided by 6 factorial, which is going to be 6 times 5 times 4 times 3 times 2, you can see that we're going to have some numbers cancelling out here. We've got a 6 and a 6, a 5 and a 5, 4, 3, 2, 4, 3, 2, and we just end up with 8 times 7. So you can sort of see how these factorials will kind of cancel each other out in almost an exponent-like manner if we divide factorials by other factorials. And, similarly, what if we had 5 factorial over 7 factorial? Well, you can sort of see all this 5 times 4 times 3 times 2 is all going to cancel out with the 5 times 4 times 3 times 2 on the denominator, but remember, we still got this 7 times 6 out front here, which isn't going to get cancelled out. So that's going to be equal to 1 over 7 times 6, or, just 1 over 42 if you want to simplify. So to write out a nice general form for how we do factorials, if you want to maybe take some notes and have a look at this every once in a while when you do go through your notebook and remember this so that it sticks. But we can say that n factorial is equal to n times n minus 1 times n minus 2 times n minus 3, etc., etc., all the way until you get to what will be, eventually 1 times 1. And so yeah, that's a nice rigorous definition for what a factorial is. And I hope this makes a lot of sense, and I hope you see how interesting it can get when we start dealing with applying this to counting problems.